Course 3, today we are finding the surface area of cylinders and prisms, so sort of strange shapes that you may think are very challenging to figure out square footage or whatever around the outside, but it's not as terrible, and it actually does make sense if you really think about it. I usually grab a paper towel roll to show you what lateral surface area is on a cylinder, but their example of a soup can is probably better because it actually has a top and a bottom. If I said, how much, let's say square inches of wrapping paper would it take to wrap tightly a can of Campbell's soup or something, you could actually calculate that, though it's not a normal shape, because there's really three faces of a cylinder, aren't there? There's top, so that's face one, a bottom, that's face two, and then the lateral surface area is a term we've heard before, and it's basically a rectangle. Well, you might say, how is that a rectangle? It's round, you can roll it. Have you ever peeled off a label on a bottle or a soup can? If you unroll this, right, it actually will look like a long rectangle that wraps around there. So by calculating the height, which would be this side of the rectangle, times, well, what would this be if it wraps around? That's the circumference of the top or bottom. So circumference times the height of the cylinder will actually give you this square inch or whatever surface area. And then you find area of a circle, and then basically double that, right? Because this is going to be the same thing. Add all that together, you've got the complete surface area of this strange shape of this cylinder. Okay? We compute the surface area of an object by adding the area of all its sides, its surfaces, its faces, right? Sorry that keeps happening. I don't know why. So, again, on the soup can, what's the lateral surface area? The lateral surface area is the part you can roll the cylinder on, the side that rolls. That's hard to calculate unless you think of it as unrolled, which we find by multiplying height by length, which is basically circumference. So on this particular shape, compute the surface area in terms of pi means don't have to multiply by 3.14. You can just go with the pi symbol, keep things simple, and then notice the final answer. They just express in terms of pi like that. I don't know why it keeps using white. There we go. Hopefully that works. So the final answer is just expressed in terms of pi like that. So they tell us that the diameter of the top here is 4 and the height is 5. What do you want to find first? Let's do area of the top because we've done that before. If the diameter is 4, that means the radius is 2, right? And we find area of a circle. I know this is something that we're still iffy on, but we really need to know how to find area of a circle. Maybe even memorized. You take pi times that radius, and you square the radius, which would be 4, right? So this is 4 pi. If we don't want to multiply, we want to keep it in terms of pi. Which means this is 4 pi. They are identical. Most cylinders, they will be. Now how about this? Lateral surface area. Well, if the height is 5, that's this for the cylinder. And then how about the part that wraps around the top here, right? That's this right here. That's the circumference of these circles. All right? So circumference of a circle is a little different, isn't it? That's diameter, or 2r, times pi. Diameter is, in this case, 4. 4 times pi. right here. That's how they came up with that. So you multiply these together to find the area of the lateral surface area of the part that rolls, which would be 5 times 4 pi is 20 pi. Then we had the bottom and the top. We add up all these faces. 4 plus 4 is 8, plus 20 is 28. Don't forget to label. We're doing surface area, so it's squared. And they didn't tell us what it was, so we just called them units. Square units. How about a prism? A tent is basically a triangular prism. The base is a rectangle, right? But if we created a net of what a tent looks like, the front here unfolded, the back, and then you've got the slanted parts, like these parts right here. That's slant part 1, slant part 2, and then this is the bottom. Just giving them little, abbreviated labels so that you know where I'm doing. If we think of this tent as standing on end, so that this is the base that matches up with this base, okay, area of that triangle is 4 times 6 divided by 2, so 12, but you have 2 of them. That's a 12, sorry. But you have 2 of them, so you don't really need to divide by 2. The front and the back together are 24. Area of the 2 triangles. Now, instead of adding up the other 4 faces, right? 3 faces, I'm sorry. 1, 2, 3. The base, slant 1, slant 2. We could call this a lateral surface area, believe it or not. Because when you unfold it, what we get is really a long rectangle here, right? 6 by 5 by 5. 6 by 5 by 5 rectangle, which is the perimeter of the base, perimeter of the triangle, times, if we think of it as standing on end, the height is 7. So to find the LSA in this case, the lateral surface area is perimeter of the triangle, which doesn't need a formula. Unless you are missing one, then you have to use the Pythagorean. Times what? Perimeter of the base. What's lateral surface area? Perimeter of the base times height. Or in this case, it's kind of the length here because it's it's sitting on the lateral surface area. It's like if we took that soup can, we set it on its side. We have to imagine tipping this guy over so that these we think of as the bases, right? That's what I'm doing right now. And then we think of this as the lateral surface area. So, perimeter of the triangle is 6 plus 5 plus 5 would be 16 times, what's the length of the tent? I've kind of crossed everything out at this point. I think it was 7. 7 times 16. I wonder if we're going to get the right answer. I've done a lot of messing around here. And you can do it this way. This is a different way. This is the old way, but I'm doing it with lateral surface area now, which I think I've already talked a little about in this year. 2 times 1, 62, plus 24. We had 16 times 7. Oh, this is 11. I'm sorry, not 16. 112. 16 times 7 is 112. That's the lateral surface area. Notice how I'm keeping everything organized. I do my work over here, and I summarize and do the final work over here. That's a good way to do it. LSA is 112. Now add it all up. 136. Don't forget surface area feet squared. Hey, we got the right answer. So lateral surface area of a prism, the LSA of a prism, is the area of the faces between its bases. It rhymes. Area of the faces between the bases. If it's a tent, you have to think of the bases as the front and the back. So you take perimeter times height, basically, of a cylinder or prism. It's the same. And it really does make sense if you followed at all what I was just doing. So let's take a look here. Example 3, Hector wants to paint the exterior wall, the outside walls of his shed. Find the lateral surface area of the shed. We're going to act like the roof doesn't overhang, even though it does appear to a little bit. We're not going to try to paint underneath there. So we're going to treat this like I guess it's kind of a rectangular, triangular prism. It's a triangular prism. It's got some height to it. It'll be interesting to look at. Let's find LSA by taking perimeter of the base times the height. The perimeter of the base, we're going to use the base like it's set up right now. That's 36, right? 10 plus 10 plus 8 plus 8 is the perimeter of the base, the distance around this bottom part. And we'll multiply that by the height. That's going to give us this bottom part, okay? That's not telling me anything about this top. 7 times 36. 252. Oh, I see. Exterior walls. So we are only doing this part. We could try to find this part by making it a separate problem, but you don't paint roofs generally. So they only wanted the walls. That's why they kept this. This is only an example 2. If they wanted us to paint the roof, that might be 10 lessons down the line. They might throw you something like that, which we could do. But they just had us do lateral surface area because you don't paint the bottom of a shed. You don't paint the roof. Okay, let's do A and B and D. A, B, and then tell me D.